Okay, so it's now me between you and lunch, which is an unenviable position, but it also gives me the opportunity to kind of go over by at least 20 minutes, which is always a good thing. This year I will actually try to be a little bit more formal than last year, because last year I obviously managed to insult the, Austrian hero, which happens to be my hero as well, by imitating him badly and some other things. So I won't show any revealing videos this year. I won't show anything else, but I would like to start by at least thanking one of the other speakers here today, Brent, who actually showed a very good view of the future of storage. I do have a question for Brent. How did you get hold of our roadmap? And you shouldn't actually show that publicly, right? So, but anyways, we can talk about that later. Anyway, the one thing I want to talk about is not as much product, because we haven't really done that much new products since supercomputing, etc., and you should be aware of most of the things we've done. But I want to tell you a little bit about the process of building a large HPC reliable storage solution and what that actually means from our point of view. But before I do that, I really want to mirror some of the other speakers where it says that we are extremely committed to the open source of Lustre. We are very much basing our entire product on the Lustre going forward. We are part of the community. We have a large development team. We're still trying to define how large that development team is, but if we actually count everyone involved in the Lustre development as well as the software backend for these applications, we are pretty much on par with WAMcloud now, by almost 70 people doing that. And it means that we try to do as much in the community. We may do things a little bit different than WAMcloud does, because we focus on our own hardware and actually have a solution that's an end-to-end solution developers. But we're also looking forward. WAMcloud is part of the Fast Forward. We have a similar initiative called the EIOW, who's led by the original author of Lustre, Peter Brahm. So a lot of things is happening there as well, and you should keep a little bit on tune with that, because that has some interesting connotations for the future. The other thing that might be interesting, and you may have heard about, is the fact that we now own Lustre. So anyone here who has mentioned Lustre today, you owe me 10 euros for using the name. Honestly, the reason why we wanted to get Lustre out of Oracle was manifold. First of all, we are not forking Lustre. We are not going to change the way the community is working. We are not going to try to take over the world. We are not taking over the roadmap for future Lustre. It's well in its hand where it is now. But what we really want to do is make sure that Larry doesn't suddenly decide to say, you guys can't use Lustre anymore, and actually go through every piece of documentation we have to change Lustre to whatever the new name would be, is something none of us wants to do. Secondly, Oracle has been sitting on the Bugzilla database and all the documentation for Lustre for a number of years, and we haven't had access to it. Every piece of development that went into 2.0 frame is locked down by them, and we want to open that up again. And all of this is part of the open source community. So the bottom line with this acquisition is we may actually own the trademark, but it's now owned by the open source community. That's the important thing here. And as I said, we base everything we do on a Lustre and a future. So it won't change anything. It just means that the threat of Oracle doing something with the Lustre name and the concept of Lustre is removed from the list of possibilities. So from a Xyratex point of view, we are an end-to-end company when it comes to the ClusterStor application. We are part of the open source community. We're part of OpenSFS as a promoter. We are part of the EOFS. We also have a number of developments that we've been doing. If you look at the roadmap, you'll actually see Xyratex has at least a little bit claim to fame with some of the new features in the Lustre 2.4, etc. A lot of the things that we did for Lustre 2.4 you won't see as a big feature, but a lot of the reliability features that we see have been developed by us because we had to, and I'll get to that. The other part of this story is the fact that we are a hardware company. We develop enclosures, we develop servers, we develop an appliance type or an appliance-like Lustre enclosure that is based on the open source code, which is really important. And that means that we are currently the only company on the planet that develops Lustre features, that develops hardware for running Lustre on top of it, that can support that entire stack, a single throat to choke. Now, we don't actually sell anything to you guys directly. We go through partners, and some of our partners have been fairly successful. But I'll get to that later too. So what I really wanted to talk about is where we go in the future. Yes, we have Lustre as the fastest file system on the planet. And that's what many customers want. However, that's not all they want anymore, because reliability is really important. Manageability is even more important when we start to get to multi-petabyte sizes. Data integrity is really important. The concept of data corruption happens now and then, but that's kind of okay, is no longer okay. The concept of downtime is no longer okay. So to be able to create a solution based on enterprise features, you need to do a lot of things. And as a discussion I had yesterday with an unnamed person in this room, people don't really put /home and home directories on Lustre. Well, the thing is, we're starting to see that more and more often. That means other things such as quotas needs to be enforced and some other things. And all these enterprise features is something that will change what Lustre is today into what Lustre will be in the future. Backup, HSM, all of these things is really important. So what I really want to say about when we do things, as I said, we are a company that builds hardware. We don't only build hardware enclosures. We actually also build test equipment for disk drive manufacturers. More than half of the 3.5-inch drives in the world has been tested by a Xyratex piece of equipment one way or another. That means that we know a lot about disk testing. That means that we don't actually accept disk drives from the vendors without testing it ourselves. Now, that also means other things for reliability. So the disk drive is an important thing. The next step is obviously having enough redundancy in the hardware so that there's no single point of failure. And sometimes you actually need to make sure that there are a backup to the backup if it's a critical function. Once you've done that, you actually need to integrate things and actually build things so that it's stable, it actually works as advertised. We don't believe on actually building on site. We build in a factory, and I'll get to that too, because I think that's another very important aspect of these systems. And finally, software is really critical to get this to work, and I also get that a little bit later on. So if you look at the disk testing first, when we get disk drives from a vendor, we stick in a large cabinet, and we do reads and writes to every sector of that drive for 24 hours. When we do that, we actually need to increase the temperature of that space to 45 degrees centigrade, and then back down to 5 degrees centigrade, and then back up again. Now, any drive that survives that for 24 hours goes on to the next set of testings. Now, we do ship back a lot of drives to these vendors. These vendors says, you know what you're doing, we accept this. What they actually do with those drives afterwards, well, I don't know. They don't trash, and I can tell you that much. But once we tested the drives, we think the drives are good enough. They're put into enclosures and tested again, because we need to take the next step of that. How does the drive actually interact with the SAS backend and all these things? And thirdly, when we actually have a file system running on these things, we need to test it yet again. So we test a lot. We spend a lot of time testing things. What does that mean for us? Now, this is a curve of every drive that we get back from our customers. And if you look at the standard SAS drives, and we only use SAS drives, if you look at the standard SAS drive from a vendor, most of them quote a yearly annual failure rate of about 0.7 to 0.8%. If you look at our lines here, the dashed line is the medium of these drives of our families. We are between 0.2 and 0.3. The reason for that is that we already weeded out many of the bad drives. This little peak here is because one of our vendors, or our customers, and I won't mention which, decided to stockpile every broken disk drive for 6 months and then ship it back, so they ruined my curve badly, unfortunately, but that's kind of it. But this is kind of what we expect. Now, when you build a large system, let's say you build a system capable of doing 1 terabyte per second. Now, in our case, that's about 17,000 hard drives. Now, if you have a failure rate like some of the other vendors of 3%, and you have 17,000 drives or more, that means that you have a drive breaking every day, or 2 drives every day. That means that your file system is always in a state of rebuild. It will never actually be fully pristine. In a large system like I was speaking about, a 1 terabyte per second file system, we actually expect 40 drives to break within the first 6 months as a max. The real number is 21. That's how many we've lost in 6 months of full utilization, doing benchmarks, doing acceptance testing, some other things. We think those numbers are really good. Hardware redundancy. Well, one of the things about hardware is the fact that hardware tends to break. Now, fans will always break. We know that. That's the biggest, biggest component that fails in most systems. Hard drives is probably on par with that. However, you'd be surprised how often you have bad power supplies or bad PDUs and so on. So these things need to be very, very redundant as well. And that also means a lot of management of these things. The other thing that is important is to make sure that your HA is really, really solid. Now, I don't know how many here our customers have actually bought a Lustre file system. But when you got a file system on site and you actually start testing it and it's up and running, how often has a vendor come up to you and says, oh, put that server out, make it die, jank that cable out, power off that node, see what happens. Just to make sure that you understand how resilient it is. How often do you see that? I bet you don't see that very often. We do encourage our customers to do exactly that. Because if they see a system actually doing a smooth, nice, secure failover, and then be able to fail it back immediately afterwards, they know that they have a tested, reliable system. And I think that is something that you should expect of today's systems. And that is what we deliver. Management. The fact that you often have a management system on top of your existing system is written by a different company often, sometimes, and you have that kind of dichotomy. Yes, there's collaboration, but it also means that who do you blame when things doesn't work? The hardware vendor or the software vendor? Now, in our case, we do an end-to-end stack that actually does everything. I'll get to that later on. And finally, we got the high-performance interconnect. Well, there is pretty much only one vendor today, and I don't want to bash them too much, but anyone here has run into a problem with FDR yet? No? We must be the only company who had a problem with the FDR code initially then. That's probably because we don't really understand InfiniBand or whatever. But it comes down to the fact that all these things are difficult to get to work together. And again, I think that having an end-to-end approach for the entire application stack, hardware, software, is really important. Now, when it comes to enclosures, this is our claim to fame in the enclosure business. It's a 5-rack box with 84 drives. It's the densest Lustre platform on Earth. Might not be the, on paper, densest hardware platform on Earth, but what you don't actually notice locally is the fact that these 84 drives actually has 2 embedded servers in the back. That is our RAID controllers and our OSS servers, as well as most of the connectivity. That means there's no extra servers for OSS. There are no extra rack units being used for RAID controllers. Everything is embedded in those 5 use. Fully redundant fans, fully redundant power. Every component on this box is hot swappable in the field. And we can do that without downtime. And that includes side planes, it includes servers, it includes power supplies, obviously. Disk drives, no-brainer. And it makes for more resiliency and more supportability in the field. The actual servers we use is a standard Intel chipset. These are Sandy Bridge-based, latest version of the systems, but it's a form factor that's dedicated specifically for these servers. And again, it's a hot swappable server. How many OSS servers are hot swappable? Actually, so hot swappable that if I pull this server out, stick a new one in there, I have a new MAC address, I have a new InfiniBand address, I have a new ID numbers for that, new logical IDs, etc. Our system will actually detect that, figure out, but, oh, you partnered to the one that's sat next to it, then you should have this installation stack, you should have this ID, you should have these IP numbers. And it actually do that setup itself. And again, you should not have to wait for for a support engineer to come on site to be able to do that. If you know how to pull that little lever out there and connect 3 cables in the back and stick a new one in, reconnect those 3 cables, you can actually upgrade or replace a failed server yourself. I used to argue about the fact that if my sales guy can do this, anyone can do it. And he's not very bright, by the way. So it's a very dense platform. Now, the other thing about having this dense platform is that this server, which is our rate controller as well as our OSS, pulls less than 200 watts. Power is really important going forward. That means that we can drive an entire enclosure. So when we run this enclosure at full tilt, with all the benchmarking running, etc., every disk drive is fully active, this entire solution, including 2 OSS servers and rate controllers, peaks out at about 1.71 kilowatts. Now, nobody can match that. And add to the fact that this little box delivers about 6 gigabytes of file system performance using the right drives. And these are IOR client-based benchmarks. It's not theoretical aggregated disk throughput. These are measured benchmarks. And we can do that in this enclosure. And again, this is fully redundant. Everything is double on these things. That means we can build a rack like this. And one of our partners, who should remain nameless, installed about 30 of these somewhere in the US. That system now delivers 1.1 terabyte per second sustained rates. And that's been based out of 17,000 hard drives. It's really, really dense. Now, in order to actually run at that level meant that you had to do some changes in Lustre because Lustre was never really tested at this scale before we did it. Or I should say, they did it because we obviously had nothing to do with it. Because we are an OEM company. But the end result, and I actually don't know exact number, but Brent can probably put that up. We put back something like 200 patches to Lustre, or modifications to Lustre into the 2.4 that came out of this to be able to reliably run at 1 terabyte per second. A lot of fixes. Now, all of this benefits the community going forward. And that's, again, one of these things. You can never really test this in a lab until you get into a customer and have a customer like NCSA pounding your system to pieces or trying to. This is just how we cable thing. Everything is doubled. We have 2 management network per server. We got a fully redundant network. We have in-rack switches, again redundant. Everything is redundant because we believe in redundancy. And that's just one of the things we do. I like the fact that these rack looks very wide, so these are probably wider than normal, at least on this screen, but whatever. Software resiliency. Well, HA is really important. Having to be able to do failover in a reliable and predictable manner is really, really important. Back in the old days, you had a cadre of support engineers on site or sysadmins, especially if you're in the education circuit, because the sysadmin is 13 to the dozen there, right? So it doesn't cost anything. You just feed them pizza and beer once a week and they're happy, right? But nowadays, that's not quite true anymore. I mean, people cost money, and money is not that easy to come by anymore. So the system needs to be self-reliant, it needs to be self-fixable, etc. And that is one of the other things. Now, the last line here is data protection layers. We don't run RAID because that's the only way to get good data protection. However, we keep hearing about data corruption, and no company seems to be immune to that. But it's one of these things that needs to be fixed very soon. In our case, we're using T10diff to do that, but there are other mechanisms to do that as well. But it's really important getting that as a standard component without affecting performance. Testing. Well, as I said earlier, we do test a lot. So when we actually build our racks, we build it in the factory like this. On the pallets, backed up against a cooling door so we can actually run at room neutral temperatures in there. we install everything. All the cabling, all the software, all the hardware, everything is cabled in the lab. And once we've done that, once we cable everything, brought it up according to customer specification, we run soak testing on this for up to 30 days. We actually do a burn-in in the factory before we pack and ship it. And again, this is just to be able to weed out any bad component in the system. And that means we can actually get on site with a rack like that, roll the rack off, put it in this dedicated spot, connect the power, connect the InfiniBand, connect a management cable, do a little bit of setup on the front, and actually connect clients and do an I/O in less than an hour. That's the fastest I've ever done it. I had one of my colleagues doing 3 full racks in less than 4 hours. And that's from offloading from the system, putting the disk drives in, powering it on until you can run customer I/O or data I/O. I think nobody else can match that. And again, that's because we've done all the work in the factory. When we ship it, it looks like this. It's one box with a rack and one box with the disk drives. We could ship it with disk drives internally. We choose not to because of the fact that some shipping companies, and I won't mention any specific Italian transport company that's driving from Milan up to Lugano, but some of them can't really handle the weight of these things, and they don't really understand how you secure it in the back of the rack. And the fact that he looks really funny as a, well, when I put it in, it was in the front end of the truck, and now it's in the back end of the truck, right? Now, that rack had actually moved several meters doing that transport. I have no idea how he was driving, but interesting enough, we brought it into the CSCS facility back in the Mano days when they were on the other side of the mountain, and actually managed to bring it up in a couple of hours. There was a little bit of extra fix we had to do because one of the cables had come undone there, but we still could bring it up. There was no dead on arrival things. So we know this works. Now, then we have the ClusterStor Manager, which is our end-to-end. This not only manages the system, it actually installs it. That means that every installation in the factory uses one small file with just a designation of names and some IP ranges, and the rest is done automatically. That means that every installation is identical, regardless of size. Every code base is identical. Now, this entire tool is based on a lot of open source software. You can see the list down here, and for those of you who do system management, none of these tools should be very unfamiliar. All of these should be fairly standard tools, right? And we think that's really important because open source is the only way where we can do enough new stuff, enough modification, enough feedback from the field to get better reliability. I got one more slide. And so on. So we think that's important too. The fact that we embed everything, that we script everything, doesn't matter because you can still access everything. Yes, this is an appliance, but there are options for it. Now, that's interesting. So I do have a question for the customers in the room. That actually means all of you guys, right? It's not lunch quite yet. Wake up, for God's sake. So one of the things I would like to use, when you manage a Lustre cluster or any cluster out there, what is your favorite tools? Can I get some suggestions? What is the favorite tool you use?
For managing it?
For management, yes. Well, that doesn't manage it, just... Yes. Rocks, okay. Yeah. Anything else? Bright, okay. Not a bad choice. If you go down a little bit lower tools, like the ones I've had on the previous list, any one of those kind of feel familiar? Puppet? So if you look at today's management, and you look at the next question, what kind of tools do you not have today? What kind of tools would you wish to have when you manage the system? Interesting. So I'm not allowed to talk about this on camera, but we can take a discussion afterwards, but we do have a project for that. Anything else? You guys are boring today. What's wrong with you? A log analyzer. Can we take that offline? Anything else? Okay, that means I finish up with just the standard marketing BS that, you know, we put the enterprise into Lustre, but questions?
Any questions for Torben?
Yeah.
So, your model bases on software, right? Am I right?
Yes. Hardware-assisted software rate, yes. They are very hungry today.